Okay, so welcome everyone. My name is Mauricio Aracena. I'm the president of VRIF, or Virtual Reality Industry Forum. This is our first hybrid event after the pandemic. So it's been quite a pleasure to actually see some people. We have been working for more than 2 years by phone. I also appreciate the people who made it here in the room. Still, people have some issues to travel, but that's why we make it hybrid. So today the workshop is about volumetric guidelines masterclass. We recently released released it at the beginning of the year, the guidelines about volumetric video, and also we have a workshop about two interesting topic discussion. So today's agenda, please, if you have any questions, you can actually do it anytime. I'm not actually checking the chat, but Paul, can you check the chat if someone put a question so I can see it? So I get some. If nobody wants to speak, we can write the question there. So the agenda today is rather simple. Short introduction of VRIF, so people can get to know what we do. Then we go the hardcore of the presentations today about the volumetric guidelines. It's a short summary, but deep enough to understand what actually implies to deliver volumetric video using point cloud compression. And then we have two speakers that are going to talk about their subject. One is about VR and AR security update, preparing for our secure metaverse by Mick from Igdeto. And then we have a very interesting presentation of metaverse audio, something from Ji Jun from G Audio Lab. She came all the way from South Korea to present, so we welcome her here. And I actually appreciate that we actually discuss audio because we haven't talked much about audio lately, and this is something that I wanted to hear about. How we can improve the quality as well on the audio side. So a quick remarks on what the VRIF mission statement is. It was created in 2018, or not 2017 at CES, and since then we have evolved our mission to address more than just VR, I'm going to mention soon. But the purpose is basically improve the quality of the distribution of VR consumer experience for the consumer. So this industry forum was created by many companies that at the time saw an issue that, for instance, interoperability was complicated, and the idea that VRIF we should try to choose or select or that right recommendation on guidelines about what standard to use or what de facto standard solution to use for addressing VR quality experiences. So we are all those members active here. We have a new member we want to welcome. We tried to invite them today to the meeting, but actually since we are running parallel meeting in this organization in Fraunhofer, they're not here today, but we are super happy to announce that Interdigital is our newest member here. And we're looking forward to work with them, as well as invite all those who are actually calling in today to join the VRIF initiative. And before I forget, I want to thank our member from Fraunhofer for providing us the facilities here in Berlin, which is also at the same time having a lot of meetings about DashIF and also the Web Media Symposium that's happening today, tomorrow and Wednesday. And we are very happy to also be part of that Web Media Symposium presentation on Wednesday about the topic that's called VRIF into the Metaverse, Interop Madness. So we'll at least distribute the presentation. I don't know if these sessions are recorded because this is handled by the Media Web Symposium organizers. So the work. So originally VRIF was focusing basically on VR360. It was the big hype of delivering VR at high quality. We released our guidelines about how to deliver VR360 using basically two profiles from MPEG. One was about video port independent, which basically delivering the entire 360 video, the entire sphere as a one stream directly to the user in the device. And the other profile was about delivering tiles or video port dependent, which is called basically delivering what actually the user is seeing. So we reduce the bandwidth of the transmission, but at the same time we put some requirements on the uplink to when we actually the user gaze or look at some other place with the head to fetch the tile from the server, basically to render it in a quality, in a way that actually the user that didn't notice. So we have proposed a few profiles there that are already in the guidelines since guideline 1.0, our latest guideline 2.3, where you can see how to do that. The other track was created all the way after 2 years when we saw that the evolution of immersive service, what I call it now, evolved from just virtual reality. So we came into the industry, those AR services. We talk about also the metaverse, which is something that's happening a lot in this conference, for instance. And we define the scope in a way that we can separate the technical parts so we can easily track and discuss about that. Although those tracks may be related in some way, depending how you wanted to make a service, we decided that this would be the best way to discuss that. So when we actually created the track on volumetric, this is going to be about discussing how to capture volumetric content and create a volumetric asset, how to encode and transmit all over from the capturing to the device. We also realized that at the beginning, VR360 was basically a streaming one from server to one user, and it basically means that you were isolated. So we discovered that today social VR is becoming something very important to address. So we wanted to remove the isolation factor by addressing how actually you can have communication on social VR, which basically is a key important part when it comes to, for instance, the metaverse today and how you communicate with avatars or how you actually make real representation of yourself with more advanced technology. So you see that the social VR in some way can be linked to the volumetric track when it comes to capture a person and represent yourself as a realistic virtual avatar that you can see from the other side. And finally, and not the least, we're also addressing and discussing a lot about how to enable for a better metaverse. That's the new word we use today. Basically, 5G Edge Cloud, although we say 5G Cloud to make it more simple. It's a tool that will help us, everyone, to have a better metaverse when it comes to deliver better quality of services. So those 4 parallel tracks are discussed in our guidelines on a weekly basis. We recently released the volumetric guidelines, which basically was just a particular use case of delivering one volumetric asset. So a little bit about what I've done previously and what we plan to do in the future, although this change based on contribution driven by the members. But basically you can have a story about what's actually been done in those 4 parallel tracks. So we started with VR360 where there was no track, it's just VR360. So we delivered guideline 1.1 and 2.0. You can download here. Basically, the use cases was about OMA profile, which is a sorry for that. You will have to find yourself the explanation. Omnidirectional media format, and we actually address viewport dependent and viewport independent, as I mentioned at the beginning. And also address security aspect about how to deliver secure content with VR. Something we're going to be discussed more in details in this after the masterclass, what actually means to deal with security in the metaverse. Then we talk a little bit more on the more practical approach of VR 360, and we cover we actually did a little bit about how to actually today they have live VR deployments and addressing things like device APIs like Chronos APIs, OpenXR. And then, of course, when the times pass, we find new devices with better capabilities. So we decided to also cover 8K viewport independent, since today you have quite capable device of decoding 8K, and given the fact that today we have 5G in some places, it was good to reflect how we actually can deliver end-to-end 8K directly to the device using 5G. We also actually have a paper publication in the SMT conference in 2020, I believe that's the year. And we talk about that, but it also is written in the guidelines. And then we took more on the new profiles of HEVC when it comes to OMAP. But basically, VRIF was the first as an organization to address that we need to have 8K. And at the end, basically means that the MPEG standard, based on our suggestion, they decided that we should not link or constrain the OMAP profile towards a level of the video decoder. So basically, that now it's called unconstrained, so you can put any type of resolution on that profile. And at the same time, we started to cover multiple viewpoints overlays, which basically mean OMAP version 2, which means that when you actually build a VR experience, you may have, for instance, several cameras in a stadium, and then you have one camera that's in a goal, and the other one close to the public, and then the user can easily choose which viewpoint to choose from an application perspective. That's basically what's covered into the viewpoints overlays. This is also standardized in OMAP, and we took a description of the guidelines on the 2.3, which is the latest based on VR360. And then, which is a core topic today, is about volumetric guidelines, which I'm going to talk about content production, storage and compression, reflect on point clouds and meshes. I'm going to talk about that one, how to distribute, and what type of use case we're actually considering there. We haven't done much of the social VR yet. From a guidance perspective, we have done in some speeches in different speaking opportunities and different industry events. But understand with 5G cloud, that's something that we have in the pipe as we are busy with mainly volumetric. But we have a lot of presentation of 5G cloud that you can download from the VRIF webpage. And then we're actually working today is about the next step on volumetric. This is yet to be seen what we have, but definitely we want to look for maybe new profiles, reflects about new codecs if it needed, and try to do some interop. But that's something we're going to announce once we have a draft to publish. Okay. Any questions or thoughts about VRIF scope you would like to share or comment? Okay, take a deep breath. We are going for the masterclass now. Okay, so this is the first part that's probably going to take between 20 to 30 minutes, depending how inspired I become, and of course of the questions you may pop up there. So let's talk about why we want to address volumetric, and then how you capture, how to stream, and which profile we selected in order to actually have a good service that everyone can use. So these are the basic volumetric use case we consider. First of all, when someone produces an object from an array of camera, you produce what we call a volumetric asset. This is the first step that we address in the guidelines. So basically, you have a boxer there. That's what we call a volumetric asset. So the user can consume the content and see from different viewpoints. If you wear a VR headset, you move around, 60 degrees of freedom. If you have a tablet or flat screen, you move with the finger around from different viewpoints. That's the idea. Or with AR glasses at the same time, which basically means that overlays the image over a table, and then it's like basically what's described in the picture taken from BT Sports there. And by having volumetric streaming, you actually can have this personal view at the end. I mean, this is super advanced. It basically means that, for instance, you have a stadium with a set array of cameras around this field, and then you create 3 viewpoints, whatever you wanted to look at that one. You can generate based on where you wanted to place in the middle of the field and see like a first-person shooter or first-person player by generating from the different cameras. This is the very high-end use case that we like to see from volumetric capture. But a more realistic one is the one you see in the picture. I mean, you normally have a live stream from a boxing event. You normally have cameras around the boxing field or the quadrilateral, I don't know how you call it, the square. And then you can in real time capture the two, and then maybe send it for a second feed, a second screen, which you call XR, and then consume over the AR glasses, for instance. So basically, you can see around in your table at the same time you watch the feed in real time from the TV. That's sort of one use case. The other one is about realistic representation of yourself. I mean, this is more like metaverse communication or hologram, where you can see from Star Wars movies, for instance. This is not that far in the future to realize that one. We may have a challenge of having a proper camera array that can be portable enough to go with you around it, but from a technical perspective, from an end-to-end to deliver that one, you can do it today. Maybe not with the best quality you can, but with some points that they can represent and feel yourself. So this is basically making yourself realistic in a volumetric sort of representation. So that's why we address volumetric. It has a lot of use cases you can deal with and improve the immersive consumption of whatever set you want to do. So let's talk about how you actually today the volumetric video production workflow works. So normally you have an array of camera or an array around you. So normally today most of the studios are outside in, so your camera is around the subject. It's not like you have live field capture, that's a different case. We haven't addressed that one, although it's a production aspect, not delivery. But the production that we address today, that you have cameras around, and then you capture different angles from this one, you calculate depth estimation, and different sort of formats from RGB and differential as well information, and then you create a 3D representation point cloud of an asset or a sort of a group of objects. And then you have two ways of actually doing it. One is using point cloud, coding, and then stream, and the other one is using mesh encoding, which will require a little bit of processing. So there are two today paths that you can deliver volumetric asset, point cloud based path and mesh based path. I'm going to talk about a little bit different there. Before going that, we did a little survey of a volumetric capture system today. You can see that they have different camera type. They have different number of cameras. You can see that some of them use 32, some of them use 53 cameras with IR cameras as well, and some of them, like in Korea, use 64 RGB cameras. And all of these one, they have their own way of delivering the content resolution, so they can get 2 megapixel, 8 megapixel, 20 megapixel, and even 40 megapixel or 8K resolution. And they already have different tools how you capture. You have maybe green background, lit background, or unconstrained. You can see some picture of the studio we addressed there. So, of course, we have our host today, where we're in Berlin from Fraunhofer HHI. And actually, VoluCap uses the same solution that Fraunhofer proposed. They are basically a spin-off from the research organization. The other company that also address in our guidance for reviews, a French one, I8, which I believe is Korean, and Mantis Vision as well, although I don't have pictures to show here. So this is a basic study. And most important, that all those studios today, they use mesh as a distribution format. So mesh today is de facto standard of how you actually deliver or sell a volumetric asset or streaming. And why we're addressing point cloud, that comes to the next step. So what's a point cloud? Well, point cloud is a set of 3D points. They're not ordered. and there's no relation between them. You just capture the point and you place it in a 3D space, right? And each point has basically a location, some attributes, color, texture, transparency, timing, and frame. So when you build a video point cloud, you need to put all together. So it's a lot of information you need to represent for. And this is a nice picture to tell you how you actually go in close to this one. So at the end, you have points in between. So what's the difference between the point cloud and mesh creation process? So the capture part is the same. It can be the same. I mean, different studios can have different way of doing it. Even as I mentioned, they can be traditional 2D cameras or light field cameras. But at the end, you create a point cloud. That's how actually you initially represent the object or the asset that you want to create. And by that, basically, you can store it. It's a lot of data, of course, it's compressed. But then the industry has made a way to make it simple to transmit to the device, and they use mesh. But in order to deliver mesh, you need to process that one. So you mesh the points that you have from the point cloud, you reduce the mesh to make it more simpler before actually to encode. So you basically do some sort of sampling of the mesh, this one using triangles and so on. And then, but that's computational quite complex compared to just directly encode point cloud. So one of the next steps that we want to address in the guideline is to actually have a pros and cons between the point cloud and the mesh. And what I can say right now is that using point cloud, it's much simpler from the capture point of view. You don't process much, you just straightforward to the encode that one. However, you have a little more processing requirements on the device, because as I learned from our members at the VRIF, the current device chips, like mobile phones, they are meant to work with meshes or triangles rather than point clouds. So there's some sort of penalty performance on the device. While the mesh processing comes more natural into today's devices, because they have a GPU that works with triangles, basically. So it's simple in the device, but more complicated on the processing of sending the content. So what we can say right now is that point cloud compression is going to be easy for the real-time applications versus putting a little more requirements on the device.
Do you want us to ask questions now?
Yes, anytime. Yes.
You're allowed to say why did you ask this question? We discussed it 100 times in our meetings.
Yes.
And it just occurred to me. We always show diagrams like this where you have a couple of people and it's clear that they're capturing the people from all the different angles. Do we ever talk about the background and how that's captured, or whether that's captured and if not, whether you decide, how do you decide what's foreground and what's background? It's obvious if they're standing in a green screen room, you know what I mean?
Yeah. So that's volumetric capture from cameras array. It's basically capturing the assets. The background is overlaid with, like in movies actually. Yes. A lot of movies are, when they have fight scene and like type of magic that is brought around, when you change the viewpoint, it's done this way. And then you overlay, you put the background from other capture. So one thing, for instance, when you actually capture an object in volumetric and make an asset, is that in a virtual reality environment, you put it into a virtual environment, so you have a different totally background. When it comes to AR, you capture the volumetric, but you place it in a real environment, like on top of a table, for instance, or whatever you want to place it, and you go around.
So something that might be interesting for us to talk about in the future is the difference. If you remember in one of the previous slides, you had a sports stadium with the cameras all around it. Obviously, in that case, you don't have the luxury of having a green screen the whole way around. So there has to be some extra intelligence to either to do something with the background, to ignore it, or so it might be just interesting to look at those cases.
Yeah, that's the input that we're looking for to continue looking at that one. But this actually was a real study from Intel, and some trials on that, and they have a real, well, it was not real time. They could create replay and image like you have in the picture here when it seems like you are in the field. Here, I hope you pointed where you see the full replayer zooming in and out, but that was generated later. It's not real time because technology today, I guess, it makes it difficult to do that. But cool. Unfortunately, this studio was closed down because of the pandemic. Okay, so let's go back to this one. So now that I mentioned what is a point cloud, that I mentioned how there's two ways to code, I mentioned also about this is the architecture we address in the guidelines. You have the capture part, we mentioned a few studios, and you have the type of device that you wanted to render. So it's independent of there many flavors you can do it. It's flat screen, but you basically, many people use today as an AR application, for instance, when they go to buy something. AR glasses, which is the one that we all want to look forward to see in the consumer markets sooner than later, and more affordable as well. And also the VR today that is more pretty much being at home, right? So then they identify the volumetric content provider, volumetric content. I have a mistake here, the distribution. And there's also volumetric content provider, but just for distribution, volumetric service platform. There are three parts that we have in the architecture. And from the volumetric content, you create 2D content. As I mentioned, you can create VR360 content, like you have the assets and then you put the movie with another background, or 3D overlays as for AR glasses. Now, what's the challenge to transmit? Is it okay? There's a nice picture of capture. So, how much cost to actually a point cloud? So, imagine 1 million points per frame, and each point has 3D coordinates, so 3 times 10-bit coordinates, and of course you have RGB values 8 bits, which is what you use today in the video, and requires about 1,320. It's more like 1 gigabit uncompressed video or volumetric information at 30 frames per second. It's quite a lot of information. And this is just for one particular object, or asset, what they call it. So you cannot just transmit it there. Mesh processing does their work to reduce the complexity. But if you actually want to add more HDR content, you need to move to 10 bits, and then even that's probably even more complicated with RGB representation. There's a lot about how you want to go to the next step. There's a lot of information you wanted to probably do there. So what we cover here in the guideline is basically the above part, the volumetric streaming use case, streaming one asset that's captured using point cloud compression. And we took a rather new format from MPEG, which is called V3C, Video Point Cloud Compression, which is based on 2D video codec. So it's, for instance, you can reuse the standard existing codec that you have already in the devices today, like HEVC. And then we use also a standard streaming protocol like dash streaming, as it used today for VRC60, or even for regular transmission of Netflix content. So we only covered that part, the above, PC point cloud encoding compression, streaming protocol, and point cloud decoding. Mesh encoding, that's the next step we want to address in VRIF to probably describe the de facto standard you have today in the industry, and because as a standard come from MPEG, it's not yet done. This is going to happen probably in a couple of years to be ready. But it's good, since we are an industry forum, we should also reflect on the fact what's being deployed in the industry. Okay, first of all, as I mentioned, video point cloud. Let me see. Okay, video point cloud is it's a sort of it's a new standard that comes from V3C, video point cloud from MPEG, and they address different type of media profile codec and codec groups, and different level of complexity and quality. So VRIF has selected a simple profile that can address most of the devices that are today in the market, and by means mobile phones. So what is important is about the level we choose here, 1.5, which defines the bit rates or the codec performance when it comes to the codec capabilities, and how you reconstruct, which I'm not going to go too deep on that one, but there's a way that we relax the constraint, how you reconstruct the image. And we did not address any new audio profile. We saw that the one that's been described for VR 360 in the guideline 2.3, it's suitable. I'm not saying good enough. I'm open to hear about other proposals on audio as well here. But basically what is being described here in the guideline 2.3, the MPH audio, which has been there for a while and still there. Okay, so what is video point cloud compression? And please ask me questions. So basically you want to reduce when this group was created in MPEG, they come to the idea that we don't want to create a new codec specific for volumetric, otherwise it would take years to have devices. So they came to one of the requirements was to reduce the standard 2D video codec. So basically you have a profile BBC that you could use H.264, you could use HEVC, and even the new codec that comes with BBC, BBC, not BBC, not WUC, something else. So, and it's not described in the guidelines. We think it's too soon to address the BBC codec, although it's super powerful, because we still don't have devices in the market. So we try to match what's happening in the industry. And basically the point clouds are converted into 3 different video streams or video sequences: the geometry of the picture, the texture, and the occupancy. And also you generate metadata, which is a way to link all these 3 video streams. So this is basically what's happened here. You capture the point cloud, you do some sort of called 3D patch segmentation, which is basically you have a cube around the object, and then you project those one as a patches, and then you generate texture. It's a smart way. I'm not going to go to that one. That's something that it's described in the guidelines how this needs to be done. Although the way how you do that, as always in encoding in video, it pretty much depends who actually implement the video encoder. They can be better than the other ones, but there is a recommendation how to do it, how to build a texture, how to build geometry, and also occupancy. And basically, you do as it is. So each of the stream you code using a 2 video coding. So basically means that you use 3 video codec instances to code that one, together with some metadata that's generated, which is not much data information that you code. It's just information to link 3 streams, and then you multiplex and you create a compressed bit stream. That's basically how it works. Looks simple from top. Although to generate the texture and geometry and the occupancy, there's a very interesting mathematical description in the guidelines you want to see, and I guess implementation is even more harder, but that's how it is in video encoding. And then you code that one, and then you do it. And the decoder is the opposite way, although faster. However, that's an interesting thing. The decoder needs to deal with 3 video encoding instances. That's still something that I need to figure out with our members, but it means that I need to confirm that. I just wanted to tell you that depending on the implementation you have in your device, basically means if you have a performance codec of 8K, by allocating 3 instances, basically means that you divide the performance of the video decoder by 3, because you need to deal with 3 separate streams. But that's something I need to still confirm with device manufacturer how it works, because it depends on the implementation it is. But if it's hardware dependent, normally that's how it is. And basically, you decode the 3 textures, and you do a magic geometric attribute reconstruction. Then you do some post-processing like smoothing, and then attribute transfer and smoothing. And depending on the profile which you choose, some of those tests may be optional. So you may get better quality but more performance impact on the device by applying all the steps. But at the end, you get the reconstructed point cloud. So interesting that you have 3 decoder instances, and then you need to all put together in the GPU basically. So it's some way the device is busy doing a lot of stuff. It's not just doing video hardware decoding. And as I mentioned before, the initial experience with point cloud decoding is that the devices today are made for triangles and meshes rather than point cloud. So that's sort of a little bit the drawback that you may find today with video PCC decoder. But as we tested with this performance, we have some number performance about the profile we tested. It seems to be quite good. How you compress the bit rate and also how it managed to render the frame rate per second based on some million points you want to see. And finally, yes.
Just one question. So you mean by this that reconstruction is done only on software level, or it's like
yes, you do some software level processing to put it together.
So you can decode in hardware, but the reconstruction of the images of the different streams is done by software.
It needs to be done because we use legacy to the video decoding. So the video decoded hardware are not meant. They're not aware that it's volumetric content, right?
Because it's just 2D stream.
Exactly. So there is some hardware performance impact by doing that, but still, in most of the XR applications, you use a GPU for that, so on. But that's the evolution how the device needs to go. As far as I know, there are new standards coming in MPEG that can address a native volumetric or point cloud compression, not using just a 2D one. That's how it's happening. But so far, it's a good transition to do that if you want to address point cloud coding.
And this is something we'll talk about in security in a second, because this is the key part that where security comes in. You shouldn't do that diagram.
Okay. Good. So, and then at the end, we have dash streaming, and basically there is no much changes on how you use dash. Also, we reflect on the single track mode. It's mainly for download content because there is no bandwidth adaptation on that one. And then you have the multi-track code with mode that you create several version of the content with different bitrates, so you can, based on the quality of the network, you can pick it up and adapt to the conditions.
So for each stream is an adaptation set.
Yes.
From this stream, you have 3 adaptation sets, and for each adaptation set, you can have multiple presentations.
I'm not an expert on Dash, but I think that's the idea of it, yes. And then let's go for device performance. So I'll give time to all the speakers. So those are experiments that done by Huawei and then done by Nokia. And you can see that there's not many phones here, but when you think about how many chipsets are available in the market, there are a handful of them. There are not more than 5 or 6 or 7. So basically, at the end, you wanted to test like 7 families of chipsets. And this one done some time ago, and this is the profile we proposed in VRIF, and can handle pretty well, even quite what we call it to the legacy one. We're talking about iPhone 6, Google Pixel, which is quite old. We plan to update those results in the net guidance to how to actually perform the newest chipset. But so far, you can see, for instance, that when you decode 1.6 million point cloud at 60 frames per second, it can deal with pretty much 30 frames per second rendering. So it's pretty good. So, and also a reflection here that all those phones can decode 4K traditional video, called 4K 30 frames per second. So basically, what we can see that a phone that's capable of 40K 30 frames per second decoding, which of course performance of the GPU adding on that, it actually can decode the profile that we propose here. Hands-up demonstration here, you can see this is 25 megabits per second to the left. This is using a flat screen to the left, the lady that's been around in the presentation. And this is with 13 megabits per second. I guess some people still think it's quite high bit rate, but I believe that for a good quality you need to that one. But yeah, that's the initial use case we addressed, volumetric streaming of one particular asset that could be useful for the use cases I described at the beginning. Any question before we go for the speaker? Yes?
It's possible, or other reference tools or apps that can be used for this?
We have this application in Android that you can run. It hasn't been maintained from some time ago. Once we tried internally in VRIF, we wanted to probably release it from the members to try, because it may not compile correctly with specific platform. I think we have some issue with Samsung platform, Exynos, but we will try that one. And then if it actually goes quite stable, we wanted to actually give it to the more open communities to try. And then also to give a feedback on the performance with different devices. Yeah. That's also a good thing. Yeah. So that's the plan this year at least. Yeah. Any other questions? Do we see anything in the chat? Oh, that sounds like a question. You didn't tell me. Okay. Great, Secretary. Okay, thank you. Okay, so now we're going
to talk quickly about VR, AR security, and preparing for the secure metaverse. So we've got the metaverse buzzword in there. So I'm Nico Doctor, I work for Ghetto, and we have a long history in security. It's pretty much it's where we come from, what we do. About over 50 years, about 1,000 people, 70 to 80% of whom are engineers working in security. Just introducing myself. So, VR, AR security, and metaverse. So, important to actually say what the metaverse is before we talk about this, and it's a tricky one because I'm not sure if it's ever been officially defined, but essentially, certainly the way I think of it is it's basically a way of connecting up lots and lots of VR, AR, virtual reality, and augmented reality domains, so that you can move between them very much the same way that you move between web pages and so on the internet today. I think that's the easiest way to think of it. It's like the VR equivalent of the internet. And as soon as you start thinking about it that way, it becomes quite easy to try and understand. It's quite easy to understand where the security implications are. Okay, on to the next slide. So just looking at some of the concerns you might have from a security point of view. So first of all, you want to protect your users. So you want to protect people from inappropriate content, verifying what you're seeing and you're communicating with. Some of the examples we typically see at these types of events are things like remote surgery and diagnostics, somebody fixing a nuclear power station from afar and so on. You really do want to make sure that the surgeon, if he's remote, wants to make sure that the images he's getting are really accurate, are very accurate, are 100% accurate, so that when he moves the knife or tells somebody to move the knife to the left, he's actually seeing what's going on. And similarly, nuclear power stations or whatever, or even somebody working on a car engine remotely and diagnosing it remotely, as the importance of the task being performed, moves away from maybe some of the entertainment areas to some very, very serious applications. It's very, very important that you are sure that what you're looking at is actually what's on the other end, and somebody hasn't got in between. You haven't got a man in the middle pretending to be, you know, either interfering with what you're seeing or completely replacing what you're seeing. The interaction between the physical world and the virtual world is, you know, it's probably more important with AR than VR. So VR is fairly simple. You've got a headset on and you're walking around the room, you're going to bump into things. Okay, that's quite simple. It's not hard to work out. In the AR world, it gets way more complicated because if you've got very sophisticated AR, which is able to blend real and non-real things together, you get to the situation where somebody could, you know, take an example, like you're cycling down a road and they make it look like the road's going left, and it's actually going right. And there's many, many other applications that, you know, they put something in front of you that makes you jump to the left and you fall off the side of the cliff or something like that. There's lots of reasons why, you know, fairly obvious security issues that we can all understand. You don't have to get into that. To be an encryption expert or a crypto expert to understand it's not a good idea to sort of turn left at a right-hand bend. And then, of course, we have all the usual personal data security issues. In the VR and the AR world, there's extra information because there's a whole bunch of information being sent back, sometimes to the server side about your position, about the way you know, your orientation, how you're looking left and right, how you're moving, and, you know, who knows, maybe, in fact, I think it's actually a noted fact that people, the way people walk or something is as much as a fingerprint as their actual fingerprint. So maybe the way you react to these things becomes a fingerprint as well. There's lots and lots of data protection and privacy issues there which need to be considered. So protecting service providers. So service providers where most of us, pretty much all of us, are our customers. So we want to protect them so they make lots of money and pay us. And we want to make sure that a lot of the things that I just described happening to the users, bad things, service providers want to make sure that they're not enabling any of those bad things to happen to their users because then they become liable. And also all their users either fall off cliffs or become unhappy with the service.
I got your slides. I
got my slides?
Yeah, I want to share.
Okay. So I'm not going to go through a lot of detail here, but a lot of the protection of a service provider is around making sure that you meet the, you know, protecting the users and the content owners as well. So we go on to the next slide as well. And you know, a lot of service providers, especially nowadays, are content owners as well. So content owners, this is the sort of the traditional thing that most of us in track video would be familiar with, basically piracy and anti-piracy. So if somebody invests a huge amount of money, and they do invest huge amounts of money making content, they don't want the content, you know, they want to get paid for that. They don't want the content being pirated and copied and streamed illegally or shared illegally and so on. So they want to protect against copying content that's streamed or that's delivered in some format. That they want to be able to provide content and service to entitled users, and by that, you know, you might have different levels of quality or different, you know, once you start getting into VR and AR, the type of features you can add, you may have more features for premium users and so on. You want some way to control that. And if content does leak, you want some way to trace that content back to the source of the leak. So we've discussed this in these groups before. A lot of the content protection is based around encryption. A lot of the content tracing is based around forensic watermarking. But how it applies to the VR AR world can sometimes be quite different. Move on a slide. So what is the impact of the metaverse? So I guess first thing to say, as we mentioned earlier on, is like in the 80s, you had to add turbo to every product in the world. We sure will add metaverse to every product in this today. But similar to the internet, basically the metaverse opens up VR environments to a much wider audience. So it doesn't, you don't put metaverse on the package and it automatically opens up. But the whole point of the metaverse is that people will develop their environments so that they can be open and connected to other environments. You can imagine a VR experience in one domain having a link to bring you into a VR experience in another domain. And then you can imagine somebody tracking people across domains. You can imagine some very trusted domain and a link to a less trusted domain, and suddenly you're into the usual malware. So all the type of security issues that we're all familiar with on the internet become just as applicable on what is essentially a connected network of VR and AR domains. So more visitors and users will obviously increase the risk of malware and so on. And more sites and worlds and visits increase the risk of the user being exposed to bad sites and malware. So again, conceptually, nothing hard to understand there. Now, this is where it gets a little bit trickier, and where the next slide is, or one of the next slides is one I just added in, where we had thought it would be useful for discussion. So, the question here is, what do the new immersive media formats, so the point clouds and the mesh clouds and so on, mean for those, and in fact even standard VR 360 video? What does that mean for those building the technology? In a nutshell, the key thing to remember, which I appreciate nobody will remember, and I appreciate we actually won't do this, but I'll say it anyway, is design with security in mind to avoid rework. Now, even in our own group, we've been saying that for the last 3 years, but we always do it first without the encryption and add the encryption. And even though we know that we tell, we're giving the message that that's not the right way to do it, it's just the way things work. But let's understand why that's the way we should do it, at least. Most devices now have the concept of a secure media path. Not all devices and not all applications, which, as we were talking about earlier, is why you may find that you're able to watch, for example, Netflix 4K on a browser on one machine, because that machine and browser combination supports a secure media path, but you're not able to watch 4K on a browser on another machine because that browser and machine combination doesn't. And the one you can watch it on may be a much more expensive machine and newer, but if the browser and the machine together don't support a secure media path, then content owners generally won't give out 4K content because you can essentially run a small cinema of 4K. So what they'll do is they'll reduce it down to HD content, which is far less risk for them to lose. So the reason I mention that is just because these are real concerns. You will see people talking in forums about users, our customers, end customers, talking about trying to understand why they can't see 4K when their friend can or their other computer. What a secure media path does is the kind of, when we're looking at it on the screen here, it's kind of a grayish, blackish box going across that picture there. Yeah, and that Mauricio is doing. It's actually the white one, Mauricio, the entire dark white. Showed it there. What a secure media path essentially does in very, very simple terms is the encrypted video comes into the device, it gets passed into the secure media pipeline, if you want. The key gets passed in somewhere else, not shown in this diagram, and the video is decrypted, it's decoded, and it is sent to the display all within that secure media pipeline. And nothing else is able to read that memory, essentially. Nothing else is able to look at it. So, for example, again, taking Netflix as an example, the Netflix app is running on an Android device or a Mac or a Microsoft device. It is not, even though it's video, it's company's video coming from the head end, that app itself cannot read the content. Once it goes into that secure pipeline, nothing can read it. The operating system can't read it, the firmware can't read it. And this is when we first started looking at 360 video, this was a big problem because the video that comes in is, if anybody's seen the view, it's like a fisheye view. It's sort of ortho rectangular projection, which basically means that all of the 360 view is in a single frame, and you have to do some maths on it to transform the bit that you actually want to see. The problem is that to do that maths, you obviously have to read the video frame and do it. So that actually wasn't possible on quite a few devices, and in fact nearly all browsers. The diagram that this is taken from is actually an Android diagram, and if you can see there, the purple box, the EGL, it actually provides the ability to provide some transformations on protected memory. You still can't read the protected memory, but you can apply a transformation to it. And that was built specifically for VR and AR applications, so that you could get in these ortho rectangular projections and apply a transformation depending on where the user was looking to actually produce the correct frame. But again, the key thing is you can't, there's none of those, if you want, functions that allow you to do that and work on the protected memory will allow you to read what's in the protected memory. For the very simple reason, if you could read the memory, then that in turn requires secure background would be a waste of time, because as soon as you can read the memory, you just copy it somewhere and you've copied the entire video.
What happens when you put an HDMI file?
So HDMI, so that's at the very right end of the display. So the simple answer is HDMI has a security mechanism as well, which is HDCP, which is a secure way to connect, to extend the secure pipeline if you want all the way out to display over HDMI. The not so nice answer is that it is a traditional place where people build whippers, so places to do. It's security is a game, so the newer versions of HDMI and HDCP are much more protective. And what you'll actually, again, if we just take, we should stop taking on Netflix, but if you take any of the major streaming providers such as Amazon Prime or Netflix or Disney Plus and so on, they will have, you'll frequently find that you can say you've got an iPad or something, a good screen iPad, they'll allow you to watch 4K on a computer, but they won't allow you to connect to HDMI. On some devices they will, and some devices they won't, and again, it's to do with the security level on the device. Okay, we go on to the next picture now, which is, so this is looking at trying to look at what Mauricio presented earlier on and see how does this apply, how does this affect us in the work we're doing here. If you remember the formats that we talked about, whether they're point cloud encoding or whether they are mesh encoding, they rely on work being done on the receiving device, and that will work absolutely fine so long as the receiving device streams, so long as the streams aren't encrypted. If we go on to the next slide, this is one I had, I think it's actually, I should have had initially, that's much clearer. So if those three streams, which again are the texture, basically the outline, the depth, and the texture, I can't remember what the proper word for them is. Oh, sorry, there it is, the texture, geometry, and the occupancy. If those, the reason they're being delivered like that is because, as Mauricio said, it leverages existing technologies in the devices. They're essentially just like a 2D video stream. If they are encrypted, if that first one, for example, is encrypted, then all of those operations we need to perform on it afterwards with most of today's, and it's very hard to say these things because everything changes all the time, and people, companies don't share their roadmaps when they're working on cutting edge stuff like this. But I'd say with a reasonable amount of certainty that wouldn't work today because the devices are set up not to allow you to do anything to the 2D video when it comes through. So the message that the reason why we're trying to say, think about security at the very beginning when you're designing these things is because if we design a brilliant solution, that's great, and then everybody says that's brilliant, I want to use it for my Formula One or my, my high value early release movies or World Cup soccer or cricket or something like that, the content owners are going to take a look at it and say absolutely no way, because that's, either it can't be encrypted, in which case they're not going to be comfortable with it, or it's going to be only supported on, it can't be supported on devices because they don't have a secure media path. So what's the answer? Because, it's easy to point out the problem. What's the answer? I think we discussed it earlier on, and we've discussed it previously. Part of the answer is just getting the message out there to the people who are working on the standards and are working on the devices, so that they can essentially work together to come up with either enhanced capability in the devices so that that secure media path pipeline can support those operations we need to do, or else a different, enhancements to the media that's delivered so that there's less transformations required on them or no transformations. And it's probably going to be somewhere in between, some combination of those two. Okay, I think that's it for a quick refresher on security in the VRIO world. Does anybody have any questions?
Yeah, I have one, since I have some legacy experience on past experience with devices. Is any secure pipeline involving a GPU in the market?
So the way a secure pipeline, I make it look like it's a single thing there, yeah. But the way it normally works is it's more to do with protected memory and certain operations only being allowed to do that. I honestly don't know the answer. I suspect the answer is that there either is a secure portion of the GPU, or more likely that the GPU is able to act on protected memory in a secure way. I just don't know the actual details. That's a good question. I think the answer is yes, but I'm not sure. I don't know how it's.
Okay. Please go ahead.
My company is developing the cloud VI solution. So we are streaming the cloud VI service to the client. In the case that my customers say think that it is very secure than other solution. If the VI is in the local server, then they think it's very dangerous. So somebody can watching this one inside that VI system. So. But still, we are worrying about that. All the content is even in the server with streaming, and your solution can protecting the copy. Yeah.
Well, so I mean, the simple. You'll see a question that comes up quite often is how can I stop people copying content I send to my device? So the simple answer is you can't. If you're sending something to the device, then people can copy it. And that's why systems like DRM, they don't stop people copying it, but when somebody copies it, it's encrypted so they can't read it. Yeah. And unless you have the key to decode it, it's useless to you. And what the secure media pipeline does is it basically, it's the place where the key and the encrypted content come together. And the only place that they're allowed to be together is within that secure path. So if your device supports that, and if it's VR360, if it's an Android device and it's relatively standard ortho rectangular projection, then it's probably safe enough. If it's something like the point that we're talking about here, I'm not aware of any devices that can today support that. What we've talked about here. I'm not saying that there isn't somebody working on one, but I don't think any mainstream devices can fully protect.
Yeah, there's one thing. Another thing is that somebody is, for example, the car manufacturer, they are designing with VR, and they providing the VR system to all the designer in home. So in that case, that they design in home, but the car company is very worried about that situation. The car design is very important, but all the designer is designing in home. So in that case, there's already part with your idea. It's not only the streaming full data, but also only one shot of the graphic is very important. How we can secure the kind of one shot of the design? Maybe somebody can come up with that we are catching that. In that case, how can?
Yeah, so actually I should have said, so no matter how complex the secure media path is and how brilliant and the cleverness of the cryptography, if you have a really, really good screen and you point a really, really good camera at it, you bypass the entire thing. You can still capture with the camera, and that's where the second thing comes in, which is forensic watermarking. So you can't stop it being captured, but you can trace the source of the leak, and then you can shut down the source of the leak. The problem you described is actually a problem that exists in the 2D world as well, because especially during the pandemic, a lot of production for big movies has been done remotely.
Yeah.
And they have the exact same issue. They don't want anybody capturing not just the final movie, but they don't even want somebody capturing just a scene because they can give away a storyline. You know the famous one in Game of Thrones where everybody gets killed basically. So if that bit had come out early, it gives the shock factor would have gone away. So they have the same issue, and maybe we should take it offline, but basically the general approach is you try and give people read-only access and make it completely encrypted. You have ways of tracing it if it leaks so that you can, and when people make changes, they tend to make them in one way to do it is to make changes in lower resolution copies and send it back to the master one where the changes are applied to the higher resolution copies.
Oh, that's the idea, yeah.
Okay, thank you. Now I give you the word to you. The audio, you speak there or?
I can speak here.
Okay, good.
Loud voice.
Yes, so then I move this.
Yes, please. Hello, everyone. My name is G. I prepared to talk as well, but no one is in here German, right? So, you can. Then I'll shut. Nice to meet you all physically. By the way, it's been 3 years after COVID. It's good to be here, to be honest. And thank you very much for allowing me to stand and have a speech about GaudiLab and our Metaverse audio. And you guys heard of GaudiLab before? Yes?
Yes.
I'm sad, but I guess maybe you never heard of it? Okay, so let me just briefly introduce about GaudiLab and maybe to recall your memory after lockdown. And GaudiLab is, in 2014, GaudiLab's co-founder, they invented technology for binary rendering solution. So that technology was adopted as MPEG-H audio standard. And because we call it Gaudio is because that the MPEG-H audio standard was held in Barcelona, where the Gaudi architecture was born in Catalonia. So that is why Gaudi and audio, that's combination. That is why we call GaudiLab. And with the based on those technology, binary rendering technology, in 2015, GaudiLab was established. And since then, we were invested and trusted by the top-notch investors, including SoftBank and Samsung, etc. And we received VR awards as an innovative VR company of the year 2017. And last year, 2021, September, we closed our Series B funding successfully. Next, please. So if you know before us, we met in exhibition, those listed. So I hope you guys all recalled your memories about that. Please. And the Star Wars filmmaker George Lucas said sound is half the experience. And I hope everyone in this room agrees with that, what he said. Yeah?
At least
Then,
half.
yeah. Thank you. And I even prepared because it's too cold. Yes, see, sound matters. And especially sound is more important in Metaverse since the being there experience is realized only when the sound is fulfilled. And Gaudio Lab has a team of 13 audio scientists. This is the size of Samsung Audio Group. And we invent core technology to lead the present and the future of audio and Metaverse audio. Next, please. But sound really matters in Metaverse, but we can't make a complete being there experience without a lifelike immersive sound for both real world and the virtual world. Next, please. And so in order to deliver being there experience for real world, Gaudio Lab invented spatial audio and also VTRS, which stands for Being There Recreate System. And for virtual world, Gaudio Lab is also heavily investing our resources to embed audio AI, like source separation technology. So Gaudio Lab's spatial audio. Next. And Gaudio Lab has its own spatial audio technology that automatically implements three-dimensional sound consideration of user movements with the IMU information and device characteristics. Yes. So this photo was taken in 2019 summer, even before Apple Spatial Audio was released. And at the time, we were working with TikTok, China Mobile, Tencent Music, etc. And we were heavily promoting our Gaudio Spatial Audio technology in China market. And we had really fun project as well. And the BTRS, which stands for Being There Recreate System. This system is for live streaming platform. And current media streams stereo, which is not suitable for Metaverse platform. And we like to use BTRS to solve these problems of a sound is not corresponding to the screen, and when you watch or when you enjoy your media, the sound stuck in your head. So the BTRS is like a live audio editing tools to deliver the full immersiveness to end users, even in the traditional 2D screen environments and also HMD device. So how it works? So BTRS is not really requiring any additional acoustic equipment like ambisonic mic, or it doesn't change any workflow in the event site, but just to recreate the sound in the field that audience is hearing with just signal processing. So I have prepared demo. Can you go next page? This is after broadcasted scene. I have not really edited, but it's just actual broadcasting. So when you go next, you might have to, oh, there's no play. Okay.
There's a PDF.
Oh, yes. Anyway, I prepared demo so everybody can come and then check our special demo.
We can upload afterwards.
Yes, okay, sure. Anyway, so we've done hundreds of these live shows. Can you go next page? Thank you. And our team spent so many hours and tried various concepts like talk shows, various genres of music to find how to provide the full immersiveness to end users. And with Now application, it's an application in Korea. It's backed by Naver, it's giant search engine in Korea. And with Now application, we have live show every day. And if I dare to say that we provide the most immersive sound experience in live performance in the world.
It's a streaming show?
Yes,
not
live streaming show. So what we have learned from the hundreds of live shows, yes, we know online has limits to deliver everything. We cannot deliver everything what you hear on site. So we adopted room impulse response, and also we like to differentiate the online experience from the offline to providing immersive presets like row 1 on stage or like with the crowd. So let's say you went to Maroon 5 concert, virtual concert, and you select row 1 or on stage. Then you can hear Adam singing as if you are on stage with Adam. That's why we providing as immersive preset to differentiate from the offline. Next, please. And the multi-camera switching production is very popular, and it has been quite a long time in the broadcasting production. But the sound is fixed as in stereo, regardless of the location of the camera or camera cuts. Next, please. So we developed AutoView adaptive audio to basically automatically we can receive camera cut information via switches, and we can send through the vMix. Then our technology, AutoView adaptive audio technology, automatically creates a sense of distance and the space around the camera cut. Therefore, we can provide natural immersive sound experience to the end users. And this is the positive feedbacks we get every day from the end users. It's only in Korean.
Ratio translation.
Yeah.
Yeah.
Yes, please. On the next. And the Dingo is one of the most popular YouTube channel among Gen Z for the live music content in Korea. And they also features our technology, BTRS. And Claudio also invests heavily in AI audio. So we call it GSEP, which stands for audio source separation. And GSEP extracts individual audio sources from complex audio mix. For example, if you put any music mix, GSEP can extract voice tracks or guitar-based tracks or drum tracks. Next one is also demo. I prepared, but you cannot really hear me. So this one you can.
Rising up through the air, but my head is standing, so we're shimmering light.
Yes, and also.
It's from a mono source? Or
Pardon?
you take it from a mono source or stereo source to make it?
It doesn't matter.
Okay, that's fine.
And also, this is it's the same technology called GSAP. It isolates the voice from the background noise. Yes, just like this. And next, please. And also, this is available free on studio.audiolab.io. So you can just log in with your Google ID. Then you can put any sources. Then you will see what you heard just now.
Cool.
So there are multiple scenarios for GSAP. And for example, noise reduction, I just show you on video call, clear voice in watching movies. So sometimes you watch, in Korea, I commute through the underground. So I like to watch my Netflix underground, but I cannot hear what they are saying. Then is a dialogue enhancement can be adopted by OTT platforms. And also, like because we can extract vocal from the music mix, you can have a karaoke application on the music streaming platforms. And also, we can easily and clearly extract vocal, so then we can sync the lyrics and subtitles automatically. And some of them are already commercializing. And also this is a G-SEPs are performance. And as you can see, this G-SEP outperforms similar technologies on the market. Yes. Yes, this is general division. That's it. That's it for the, and this is the end of the page about Gaia.
Thank you very much, G. Any questions from the audience?
I guess, so one of the applications in the VR world is when the user moves their head around,
Yes.
your system will react to that to
Yes. I have a demo actually. Do you use Apple Spatial Audio? Have you ever used Apple Spatial Audio before?
what I've seen.
So what this Apple Audio is, so you know those earbuds, the TW's earbuds. These days, each earbud has IMU sensor inside. So when you move, the IMU information is keep sending it. So we're using the IMU information to track, and they deliver as if you are in the. If you turn, you have to hear it the right ears, right, louder, just like that. We have that solution.
How, which is just maybe a whole career, how difficult is it to integrate into existing content workflows? Obviously, whenever we bring in new technologies, we need new workflow pipelines and everything else. Is this?
So you mentioned at the beginning that was
Yes.
easy, right?
Yes, this one. Basically, when we were working with now, and it's just the environment is quite rough, so we cannot change any workflow in the on-site. But
Right.
they like to deliver the full immersiveness as if they are in the on-site. So we cannot use the special equipment, and so it's just basically we will provide one laptop. And if you see let's say this is a whole working workflow in the on-site system. There's if the guys, the K-pop star is singing, the stems will be going to the mixing consoles in the on-site. The mixing consoles, every stems will go to the BTRS, those the PC, and then we will do everything automatically and streams.
So, okay, so you just tap the microphones and do the process.
Yes. Just you have to use just one PTRS system on top of their laptop, and the mixing console will just stream their stems, and then it will just streams afterwards. Does that answer your question?
Yes.
Yes, it is pretty simple.
It's very flexible. Yes.
But it needs to be integrated back into the visual components as well, right? So you're only handling the audio parts.
Yes.
And then you need to keep the synchronization with the production audio. So there's a production video and there's a production left and right stereo. How do you synchronize with?
Yes, I got your question. Can you go next? There is a switcher part.
Yes.
Yes, this one. So basically, there is a 5 cameras on the site. So there is one camera is for one lady, number 2 is second lady, etc. And the full shot is camera 3. So every camera has the whole switcher.
Yes.
So when the director on site, and they say camera 2, the switcher will automatically switch to camera 2.
Right.
Then those information will automatically send to us.
Okay.
And then we can work on that with those PC on top of it. And that automatically we will generate the sound of the immersive sound on the BTRX.
Well, yes, I've got time to ask you.
No.
So what's the delivery format? What do you deliver to the end device? Is it a dash stream with multiple? I mean, we talk a lot about dash, about HLS, different representations. So do I get a stereo track, and do I get a enhanced audio track, and do I get a video track? How is the packaging to the end device?
The packaging will be just stereo. The end device will have the.
I think what you tried to say that this is streaming, it's not broadcast. So the format.
So you've still got a, it's not a component of a signal, right? The audio is a component of a signal. It's stereo.
Yeah, that's the stereo quality. It's handled by the director, how you want it to be.
Audio is providing the virtual surrounds audio.
Yeah.
That's the stereo. So their special skill is the making virtual surround with the stereo thing. So they provide, if they bring the position, then the virtual audio is almost similar like that position.
Okay, yeah, that's good.
So my question to clarify is this is done in broadcast television or is just a streaming message?
It's a streaming.
Yeah, I understand because yeah, it's quite flexible.
Yes.
Okay, any other question? Well, I must say that it was a fresh thing to hear about audio in VRIF. Thank you for that, and thank you for coming all the way to.
I had one more question.
Yeah, please.
The interesting demo you did where you could mix and bring in different components. And another thing that's been happening a lot in the industry is called object-based media, where they have tracks or objects which represent temporal things. Is that similar? Are you separating it all out separate into different objects and then remixing them?
Yes, we are doing that as well. We like to do, actually, at the moment, the purpose of the separating those tracks is that also for the educational, for education, if you want to drum, if you're an amateur drummer, you like to have some kind of MR. It's very difficult to find one. So as long as you just find you have MP3, you use our G-step, you can just practice your drum. That is also a possible way. And also we are thinking about the AI composing as well. So.
Okay.
Stuff.
That's a lot of questions, right?
Sorry.
Thank you very much. Thank you.
Yeah, we can network. So let me go back to the presentation. Yeah. So I just want to thank our speakers, Mick and G, for interesting discussions as well. Also, I didn't wrote it here, thanks to our host that allows us to have a host. Thank you for allowing us to be here. And I hope to meet you more in person from now on. And so for this presentation has been recorded, it's going to be available with the presentations as well. And I will send you a link to you so you can download the information. And if you have wanted to join, just contact me or give us an idea or whatever. But thank you everyone for attending, and I hope to see you all more and more often. Thank you very much. And we stop